But look, we've got a lot to get through today. We've done a practice run and there's a lot of content, and we've had a lot of questions, issues raised, etc., from various individuals that people want to try and cover today. But look, the focus of today's session is about myth busting. Some of the regulatory authority concerns about proprietary stormwater treatment assets. Now, this has come about, I guess, from probably, at least from my perspective, 3 years of having discussions with councils about proprietary devices, and I'm thinking Michael's done this for about 20 years himself. Sometimes some councils raise various concerns around the application of proprietary assets, and we're here to basically talk about some of those claims and their validity. But look, for those people who are unfamiliar with Ocean Protect, look, we've been doing this for about 20 years. We essentially stop pollution from entering our waterways via appropriate stormwater management. So we have about 50,000 assets installed in the ground across Australia, and we stop about 7 tonnes of pollution on average every day. And look, our webinars are one of our educational pillars. So we've got 3 pillars: innovation, education, advocacy. And obviously the webinars are very popular. I think something like 220 registrations today for this one. If you're not already tuning into the podcast, we do a podcast every fortnight, reaching about 500 people a week, 124 episodes deep so far. We also fund a Keeping Australia Beautiful New South Wales educational module called Keeping Waterways Clean. And we're behind the scenes doing a lot of lobbying for government. But in terms of innovation, we've got a lot of technologies that we integrate into urban environments to stop pollution. They come in all shapes and sizes, and that's, I guess, the range. And look, we install these assets, and we also manage these assets as well. So various maintenance contracts and facility management plans for various locations around Australia, essentially stopping pollution entering our waterways. And these are the key claims that I was keen to go over today. So there's essentially 5. And I'm going to basically discuss each one and evaluate whether I believe they're factual or potentially false. And I'm going to present the data to present at least my perspective anyway, and Michael's. So these are the claims. Also, you might remember when you registered for this webinar, you were asked a question. And this is the question: is there any particular issues and concerns you'd like to be have discussed or reviewed as part of this webinar? And look, we got a lot of responses. So this is, I think it goes over about 4 pages, and I've basically categorized them under maintenance. And some of you guys might be familiar with some of these questions because you've asked them. And there's issues around costs, performance, approvals, and there's some other curly ones as well. So that didn't really fit into any category, but they're special in their own way. But look, we're going to try and address the claims, the around proprietary assets, and in part address some of these issues as well. And if we haven't done it as part of the presentation, we'll come back to them at the end as well. Just as a reminder also, you're welcome to put questions in the Q&A at any time during the webinar. Long story short, first come, first serve. So if you've got a question you'd really like to ask us, please put it in the Q&A. And I'd certainly encourage you to do so. And I can see everyone piling through the door as we speak. So again, it's a really popular webinar today. We usually find people come in about 3 or 4 minutes late, which is cool. So welcome for everyone who's dialed in. And I think it's an appropriate time to acknowledge that Ocean Protect, myself and Michael, we have a conflict of interest in this regard. So we're here to talk about some of the claims around proprietary assets, but obviously we've got a commercial interest here. Our business, a key element of our business is selling stormwater treatment assets, proprietary stormwater treatment assets. So we acknowledge that we do have a conflict of interest in this regard. Having said that, throughout this sort of presentation, I'm going to try and be as transparent as I can, but also I'm going to provide full references for anything that I refer to back up any claim that I or Michael have. And what I would encourage is, take what we've said today, and if you'd like, do your own fact checking. Prove us wrong if you like, or at least sort of do some research to at least assess whether you think where our opinions or data is appropriate and factual. Michael, do you have anything more to say to that?
Look, Brad, not too much, but look, it's, you know, it's about declaring conflicts of interest and how we manage them. It's pretty simple, as you said. You know, we're asking people to, you know, look at the data we present and make up their own mind. And if they believe that we're, you know, saying something that's untrue or misinformed, let us know. Absolutely, do your own fact checking. That's all we're asking, and how we manage our conflicts. So,
cool.
Yeah, let's get into it.
Look, and it's worth noting that when I talk about non-proprietary assets, I'm going to focus a lot of that attention on biofiltration or bioretention. Why is probably the most commonly applied non-proprietary stormwater treatment asset around. And when I talk about proprietary stormwater treatment assets, I'm mainly going to focus on ocean protect assets for various reasons, and the least of which isn't to avoid any litigation by our competitors about me making false or misleading claims about them or their products. Is that fair, Michael? Anything more to add?
That's it, Brad. Let's go.
Cool. So claim number one, and this is probably the most common one I hear. Parts and components of proprietary stormwater treatment assets cannot be sourced if the proprietor went belly up. So if Ocean Protect goes belly up, you can't source storm filter components, Filterra media, Ocean Guard pit inserts, whatever. That's a common claim. Okay. So in response to that, it's worthwhile recognizing that Ocean Protect, at the very least, is at an extremely low risk of going belly up. Come June this year, we will have been operating for 20 years. A very financially sound and a very secure company by any sort of measurement. But if we did go belly up, it's worth noting that Contech Engineered Solutions, which is a very, very large company in the States. Michael can talk to that, but they can provide all of Ocean Protect's assets, parts and components. Ocean Protect essentially has the license to distribute these technologies in Australia. And Contech are very, very financially sound as well. And look, if Ocean Protect fell by the wayside, I'm sure a new Australian licensee would quickly appear to leave the gaping hole in the market that Ocean Protect will leave behind if we weren't here. Michael, do you have anything more to add?
Look, not too much, Brad, just to say that, yeah, as you said, we've been in business 20 years with Contech. So we've got this very long-standing relationship with the guys over there. And yes, Contech is a multi-billion-dollar company. You know, 1,500 odd employees, been running for 80 years. They've recently purchased a company on the stock exchange and put it back to private ownership. So look, Contech is far bigger than and they're one of the biggest building and construction materials companies in North America. So, you know, whether it be Contech or whether it be Ocean Protect, no one is going anywhere anytime soon. I think it's demonstrated by our track record, really, how long we've been in business. And we've been in 20 years here, which is not much compared to the 80 years of Contech Quikrete, parent company.
Cool. So in regard to this claim, at least from an Ocean Protect perspective, I'm going to call this claim busted. Cool. Again, I'm happy to disagree with it. If you'd like to comment or just say, no, I think you're wrong because of X and Y, please let us know. So I'm going to move on to claim number two. Non-proprietary assets like bioretention are much less likely to fail if not maintained relative to proprietary assets. So when I talk about fail, I mean not function, as in not provide an appropriate stormwater treatment function consistent with their design intent if they weren't maintained. I'm going to sort of look at this now. So I'm going to show you a whole bunch of non-proprietary assets. So this is a sed basin in Brisbane. Obviously, this needs to have its sediment removed, and if it doesn't, it won't work. A swale, you know, if we don't cut down this or cut back this vegetation, the swale can't convey water, i.e. can't function. And then there's obviously a whole bunch of bioretention systems. Now, if the bioretention system has vegetation that has died, obviously the nutrient uptake won't be as much. In fact, you can get a lot of nutrient leaching from bioretention systems in the absence of vegetation. If the system doesn't drain properly because of sediment buildup, obviously that means that water can't get through through the media, through the root rhizomes, etc., and get treated. There's a whole bunch of reasons why a bioretention system will not function appropriately if it doesn't get appropriate maintenance. And I'm sure everyone's got their own examples, photo library of various assets, bioretention systems, wetlands, sed basins, whatever, swales, that are not providing a suitable function, particularly because of the lack of maintenance. And if I look at some data, so this is a council within Southeast Queensland. I can't disclose who it is for confidentiality purposes, but I've talked about this previously in a paper, which is available there. This was a council in Southeast Queensland, did a condition assessment of 44 of their council-owned wetlands. And look, half are in a good or very good condition, half are not. So average means you need minor rectification works to bring up to standard. Poor means significant rectification works, and red means major rectification works, as in very poor function, needs to basically be rebuilt. So again, reasonably, like I guess half of all assets need rectification works. And it's largely due to the absence of maintenance for these wetlands. Same thing, same council, bioretention system focus. There was 82 bioretention systems, similar story. About a half of the systems need rectification works, and about 22% in this case had failed, or at least in very poor condition, largely due to an absence of maintenance. Again, this is Moreton Bay Council. Moreton Bay Council, one of the leading councils in Australia for water sensitive urban design. They did a condition assessment of 318 of their bioretention systems. And a similar story, significant proportion of them weren't working consistent with their original design intent, and a fairly large proportion needed significant or major rectification works to bring it up to a certain standard. Again, largely due to the fact that council weren't maintaining their assets appropriately, or at least enough. This is a classic example, a bioretention system in Moreton Bay Council. A cake up of sediment build up on the surface. The system doesn't drain properly. Water ponds, looks ugly, etc. Doesn't provide its stormwater treatment function consistent with its original design intent. So again, largely due to a lack of maintenance. You know, that sediment build up needs to be removed periodically to ensure its appropriate function. And it's obviously a very difficult thing to do. You know, how do you go about rectifying this sort of asset? You know, what sort of investigations you do, who's going to do it? Is it a guaranteed outcome of success, etc.? Whereas you compare that to, say, ocean protect assets, you know, these are highly resilient. They're based on a lot of R&D, a lot of real world experience to make sure that they have I guess, a high or long lifespan and will function appropriately over an extended period of time, even in the absence of really maintenance. It's also worthwhile recognizing that Ocean Protect kind of have a commercial interest in ensuring that these assets are not an excessive cost or maintenance burden, and that they are designed and installed appropriately to ensure that, you know, major rectification works, which could potentially cost a lot of money, are not going to happen. And rectification works are reasonably easily to undertake. You know, for the storm filter, it's literally a case of often just removing the storm filter and replacing with another one. And when I talk about storm filter, it is essentially our most commonly applied asset. And look, it's very easily to replace or maintain these assets. You know, it's like a gas bottle swap and go system. You know, all of the components are 100% reusable. The media needs to be removed and replaced, and it might need a sort of a sucker truck to clean out the sediment in the chamber. But it's fairly easily done, and you know, it's reasonably simple, even for an asset that's completely hammered, like this sort of asset. You know, someone's dumped a whole bunch of, well, however it got there, a whole bunch of very oily, dirty pollution got into the system, and it's literally a case of just replacing the cartridges, sucking it out with a vacuum sucker, like it's being undertaken here, and basically at the end of that works, which is reasonably simple, you've essentially got a system that's as good as new. Now, this is Michael. You're probably best to talk about this one. This is a year-old storm filter, 20 years old.
Yeah, look, this is one of the first ones, Brad, that we installed out at Menai, but again, a Gar Aboriginal Land Council down there at Menai. I think these systems have maintenance once or twice, and this is a photo of about 6 months ago, or a shot of about 6 months ago. So again, you know, look, all the parts are washable, reusable, except the media and the pollution inside. And it is really, truly one technology that you can neglect and get back online relatively easily. The surcharge, in addition to a standard clean, would just be some extra tipping charges and probably about an hour's worth of labour, really, to bring this back from an asset that's not functioning to something that's functioning, and within a few hours as well.
Cool. And look, I showed this example of the Filterra bioretention system out at Western Sydney. This one was it's actually right next to a creek, and during a flooding event, the creek essentially overflowed into the bioretention system and deposited a whole bunch of really manky sediment on the surface of that system. But for people that are familiar with these sort of systems, the Filterra bio is that we do place a layer of mulch, a 75mm depth of double shredded hardwood mulch on the surface to essentially provide a screening function to cater for sediment loads. And after that, the mulch was removed with the sediment buildup, Mike and Blake Allingham, one from Ocean Protect, did a flow test, and long story short, it still drains perfectly well. Why? Because the filter media was appropriately protected because of that integration of the mulch layer to protect the filter media underneath. Any more to add, Michael? All good?
Look, mate, it's pretty straightforward, isn't it? Sediment will block any filter, whether it be a cartridge or whether it be a bioretention system. In the case of stormwater, we just maximize the surface area from taking it from a sort of horizontal filter to a vertical filter. So we increase the surface area 5 or 6 times. So therefore, we've got a lot more area to distribute the solids. With Filterra versus conventional bio, we use this mulch layer to capture that sediment, and we remove it annually. So again, it's not rocket science here. It's, sediment will kill any system. So let's remove it or maximize the surface area so the system can cater with these loads over a longer term. It's pretty straightforward engineering, really.
Cool. So in relation to this claim, I honestly think it's, from my perspective, it's false. It's busted. And I'd actually go as far as to say, and again, I know I've got a bias here and a conflict of interest. I'd suggest that in many cases, proprietary systems are less likely to fail if they are neglected and not maintained relative to a vegetated system. I'm sure there's examples from both sides, but I certainly think that there's no sort of appropriate evidence to demonstrate that this claim is accurate. The other issue is non-proprietary assets are much less expensive to maintain, i.e. Ocean Protect is high maintenance. Now, present company excluded, obviously, myself and Michael aren't high maintenance, but apparently some of our assets might be. So let's have a look at that claim. So people might be familiar with that paper on the top right corner, the what we call the review paper for the Filterra bios, and that for the last 2 or 3 years has included a life cycle cost assessment. And I'm just going to talk to that now. So that looked at an example scenario, typical residential development in Brisbane designed to meet the local targets. And we basically sized various Ocean Protect solutions, storm filter or a jellyfish or a Filterra system against a conventional bioretention system and a wetland. And we've basically looked at how much each of those options cost. So for Ocean Protect assets, we looked at the Ocean Protect cost database as in something that we would provide a quote for. And then for the wetlands and bioretention systems, we basically got the cost from Melbourne Water's lifestyle costing data. And now the Melbourne Water numbers are probably a bit rubbery. Ocean Protect numbers are quite accurate. That's exactly how much we would charge. But certainly Melbourne Water ones, I think from my perspective at least, are a little bit rubbery, but I still use them. We didn't include any land costs. Obviously, if our devices don't take up as much land, there's obviously savings to be gained by using some of those proprietary options as well. But look, this is the acquisition costs, the design, construction, installation, etc. And look, long story short, the Filterra bioretention system is the cheaper of the options looked at. I think the Filterra tree pits would be probably the most expensive, and then you're sort of looking at various sort of I guess variations in between. But no one cares about that because apparently the developer pays for that. And what we're more interested in is the maintenance costs. So these are the maintenance and renewal costs. And look, according to this cost analysis for this scenario, a typical end-of-line bioretention system would be the cheapest, but only, I guess, it's not a massive difference in maintenance costs. So Filterra Basin, Filterra Bio is probably second cheapest, I think. But there's a real range in costs, and certainly the wetland scenario is actually more expensive than to maintain than some of the proprietary options. Why? Wetlands are large, so at a per unit rate, they may actually be the most expensive option. But look, the cost differential isn't massive. I think I've heard this before, like ocean protect or proprietary assets are like 20 times more expensive. And from my perspective, and we've looked at various case studies in between, in addition to this, I've never seen that occur, but having said that, maybe it happens. It's very site specific at the very least. If I show you some other information, so this is an analysis we did for the Gold Coast City. So we've got 60 contracts within the Gold Coast, so 12 facility management plans and 48 management contracts or maintenance contracts. And that's essentially, particularly the FMPs, it's worth noting that our FMP contracts, which are fairly attractive from a developer's perspective because the developer can, I guess, offload some of the costs of the life cycle to the end user. But the FMP contracts include both full warranty and insurance for the life of the asset. So whatever goes down, it's a full warranty and insurance. And obviously for these contracts, we agree to maintain or manage these assets for a specific period, you know, for 1 to 15 years, et cetera, generally for a fixed sum, charged monthly. So what do the costs actually show? So this is, if I show the, just as a cost per site, which is probably a little bit hard to compare because obviously it's very much dependent on the size of the site, but this is basically generally our FMP contracts more expensive than our maintenance contracts. But if you want to sort of dig down to, I guess, something that we can sort of look at and compare and get a feel for, this is our costs per dwelling per year. And you can see here, this is an annual fee, dollars per year per dwelling for our FMP contracts and our maintenance contracts. This is for the residential contracts. And if you want to sort of put that in layman's terms, for our residential sites, that's about $2.65 on average, $2.65 per dwelling per week for our FMPs. And for our maintenance contracts, it's about $5.43 per dwelling per week. Basically the cup of a coffee. Sorry, the cost of a cup of coffee per week per dwelling to ensure that your stormwater treatment assets are functioning appropriately and protecting the health of your downstream waterways from your site at least. Michael, anything more to add?
Look, look, from my perspective, look, I love the beach, love the ocean, surfed all my life. And I suppose the last 6-8 weeks in Sydney, living here, going in the surf is, you know, been fairly horrible. It's been fairly dirty. Would I pay $5.43 a week to keep those oceans clean that I love using? Absolutely. For me, that'd be money well spent. A cup of coffee, roughly a week, would be absolutely fantastic just to see that our waterways are clean. So I think it's great value for money, honestly.
Cool. Very good. Sorry, just confirm, Michael, you can hear me okay? My audio is okay?
Oh, I've got you okay. Yep. Yep, you just dialed it up a little bit, so that's fine.
Yeah, I just dialed it up a little bit. I had just a comment. Thank you for, I think it was Jeffrey. Thank you for letting me know. I'm not loud enough. That is the first time I've heard that.
And the last.
And it's also worthwhile noting we had a lot of questions around this. You know, can ocean protect assets be maintained by others? Absolutely. Can they get training on how to maintain those assets? Yes. So the Storm in New South Wales guys, particularly Murray Powell, have put together this guideline around how to maintain assets, including our own. And obviously our assets have very fully available, publicly available maintenance guidelines on how to maintain our assets. So yes, certainly ocean protect assets can be maintained by others. The parts and components of those assets, if they need to be replaced or whatever, you obviously do need to come to Ocean Protect for those. Cool. So are non-proprietary assets less expensive to maintain? Look, it's plausible. I think it's very site specific. Certainly there'll be examples where the non-proprietary assets probably might be cheaper, much cheaper maybe. And I think in many cases it'll be the opposite as well. So it is plausible. And a sort of a note to that is that we need to recognize that all assets, all stormwater treatment assets need maintenance to function properly. And it, again, doesn't matter if it's a sed basin, bioretention, wetland, storm filter, ocean guard, whatever, they do need to be maintained. I think this idea of zero asset maintenance or WSID's zero maintenance, whatever, I honestly think is a furphy. If someone can, sorry, Michael, you want to comment?
Yeah, sorry, where does the sediment go? It's got to go somewhere. if you're capturing it, it's stored within the device. So at some point in time, that sediment will block the filter if you leave it. So this idea of there's zero maintenance, no, it's probably just a clean site and oversized technology. That'll do the same thing. But, you know, from a capital purchase perspective, systems are as small as we can possibly get them. And if we neglect them and the loading is low, you might get away with it for a certain amount of time. If the loading is high, you will not get away with it for long at all.
Yeah. I'd certainly suggest that if you are keen to do a cost comparison, do it. Do that life cycle cost analysis on potential options, whether they be proprietary or not. But those cost assessments should be appropriately informed. You know, Ocean Protect can certainly provide you a very accurate cost of our devices, because that's essentially how much we'll charge. I'd suggest getting some really good numbers around how expensive or how much it will cost to maintain the non-proprietary options. So I'm going to move on to the next claim. Non-proprietary assets provide other benefits: amenity, cooling, habitat, and hydrology. So let's have a look at that now. So look, and there's no doubt that there are lots of examples of vegetated systems, non-proprietary assets that look great, provide a whole bunch of benefits: habitat, cooling, you know, whatever. And look, I'm sure everyone's got lots of examples and they're fantastic, but obviously there's lots of examples where that hasn't been the case, where the other benefits, the amenity, cooling, habitat, are really not there, or at least minimal. And look, there's lots of examples of these around the joint. I'm just going to charge through them because there are, so look, I think everyone's probably seen sort of examples like this, and there's solutions that I guess no one really wants, and certainly no one would consider that is water sensitive urban design. And sometimes the best option is to go underground. Again, full disclosure, Ocean Protect do provide underground assets, but sometimes at the very least that may be the best option, because I guess the key benefit would be you can actually still maintain the usability of the above ground environment. Now, whether that's a car park or a road or a vegetated area, open space, whatever, at least the usability of that space is at least improved. And obviously the assets can subsequently be maintained with often minimal impact to the usability of the site, at least you know, outside some fairly short lived maintenance interventions, which might only happen, say, once every 6 to 12 months. And then I guess Ocean Protect's in the funny space so that we actually do vegetated assets as well, the Filterra bioretention systems. And I'm just going to show you a whole bunch of examples of various Filterra bioretention systems. And look, they do, I'd suggest they provide very similar benefits to conventional bioretention systems. So to say that proprietary is better, provides more benefits than non-proprietary, probably needs to recognise that Filterra bioretention at the very least is in a funny space. It is in some ways considered proprietary, and sometimes it's sort of just treated as conventional bioretention system. So in terms of the hydrology sort of side of things, look, and there's a lot of, and this is something we added actually by request from one of the registrants. They wanted to talk about hydrology. And look, it's fair to say that there's a lot of studies that show that you get a lot of water being lost within bioretention systems between the inlet and the outlet. And there was a lot of talk, well, there's some talk around these systems operating like sponges. Now, in response to that query or claim, the CRC for Water Sensitive Cities and a fairly sort of notable group of experts got together and did a review of that. And long story short, they concluded that bioretention systems act like filters, not sponges, and that the observed losses in bioretention systems are largely dominated by exfiltration. So basically water seeping out of the bottom of the bioretention system and into the surrounding soil profile or groundwater. Now that happens whether it's a base of a bioretention system or a gravel trench or underground tank, which has a leaky base. That doesn't necessarily have to happen in bioretention systems. And so the losses, any real genuine losses, are actually due to evapotranspiration, very easily predicted by equations. And if you look at the music, you know, the mass balances within the music software for bioretention systems, you generally get about 2 to 5% of the water loss between the inlet and the outlet due to evapotranspiration. So yeah, look, again, hydrology, mimicking a natural hydrology is fantastic. Obviously, we should do everything we can to maximize water reuse, exfiltration, evapotranspiration loss, but that can be achieved through a number of different ways. So is this claim appropriate? Non-proprietary assets provide other benefits. Look, again, I'm going to give this a plausible stamp. It's very site specific. Again, there's lots of examples where these assets do provide a bunch of benefits, but obviously it needs to be sort of kept in mind that water sensitive urban design isn't just about stormwater management. Water sensitive urban design includes a whole bunch of other factors. And if we're putting in assets that detract from the ability of pedestrians to move about, traffic to move about, reducing that amenity, et cetera, if our sort of policies or opinions are dictating a very strong focus towards a very blanket approach to water sensitive design, i.e. deemed to comply by our retention system, we're often going to end up with bad outcomes. And like this one, for example, this is a bioretention system that's kind of essentially under a grate on the Gold Coast. Michael, do you have anything to add here?
Look, it's a general theme throughout this whole presentation, Brad. If we size the technology appropriately and we cite the technology appropriately, we'll get a good outcome. And we're not sitting here saying, hey, put cartridge filters everywhere. We're saying if your site is, area constrained, you should go underground. Conversely, if you've got detached dwellings and plenty of space, go above ground with a vegetated solution. And this here's a classic. We're, trying to put a square peg in a round hole. We're using a bioretention system on a constrained site, then putting a lid over the top and expecting a good outcome. It's never going to happen, ever. So again, appropriately citing these technologies and sizing is key, really, to the final outcome.
Cool. Okay, so the last claim, and I've heard this a few times, non-proprietary assets are better at removing nutrients, particularly dissolved nutrients. Now, this table here, and apologies, there's a lot of data here. I recognize that. So this basically shows the results or the summary results of various performance monitoring studies of real world systems. So the cells highlighted in yellow or shaded in yellow, they're Ocean Protect, devices, Ocean Guard, Storm Filter, Jellyfish, etc. The dark green cells are Filterra bioretention systems, and the lighter green cells are conventional bioretention systems. So look, make your own, and these are all efficiency ratios, so a reduction in concentration of these pollutants, so TSS, TP, dissolved phosphorus, TN, NOx, ammonia, nitrogen, dissolved inorganic nitrogen. But look, the thing I'd take away from this is that, storm filter and Filterra bioretention systems in particular achieve very good rates of nutrient removal fairly consistently. Now, conventional bioretention system, the performance does vary. It's worthwhile noting when I say conventional bioretention system, they are using often different media mixes and whatever, and often those standards are not, those standards may not be consistent with what's considered best practice, like Forbes standards currently in Australia. But it's still worthwhile noting that there really is no proof in my mind that, demonstrates that conventional bio or other vegetated assets perform better than at least Ocean Protect stormwater treatment assets in terms of removing nutrients. And in terms of some, but again, look, these are a bunch of studies. If others have others that they'd like to, bring to my attention or whatever, I've talked about most of these in our previous bioretention webinar, but again, I'm more than happy to sort of be proven wrong. But look, in terms of just general rules, I think it's fair to say that assets that only target solids removal via, say, sedimentation and filtration are probably going to have low dissolved nutrient removal. And when I sort of talk about those assets, I'm talking about GPTs, sediment basins, and physical filters with minimal sort of adsorption capacity. Conventional bioretention systems, again, like the performance is variable, but again, I'll make this note again. There's possibly no field study to date for real events with currently recommended specifications for Australia. Now, we talked about this last time. Blacktown City Council are undertaking a project to address this issue, and that's awesome. But it's just worth noting that. And in terms of the Stormfield and Filterra, again, we show consistently high nutrient removal. Michael, do you have anything more to add in this regard?
Look, Brad, it's really, you know, what have we really done, I suppose, at Ocean Protect? You know, we've used media that's been, you know, proven in wastewater for years to remove soluble pollutants. So there's a lot of quality control around that. So, you know, we've used some type of media, you know, with zeolite, iron oxide, aluminium oxide, activated carbon that's been treated and washed certain ways. We've used those types of materials to get a cation exchange and provide some sort of sorptive capacity. So it's really a no-brainer how we remove, say, ammonium or orthophosphate. Pretty clear. It's a bit harder for bioretention because it, you know, it revolves around a lot of complex mechanisms and things happening in the cells. And the difficulty is with bioretention is we probably haven't seen a typical blend of bioretention, and there's this really awkward balance between the removal through the rhizosphere of the plant of some of these soluble pollutants versus, you know, this material is actually filled with organic matter, and depending on how much organic matter you have in, whether it's been composted or not, will depend exactly how much nutrients that will leach. So you've got part of the system removing and part of the system leaching. So it's quite a complex balance. So it's not surprising that we haven't seen great results with bioretention with, say, ammonium or NOx removal, you know, during a storm event. It's unsurprising, really.
Look, again, in the absence of that information, and we said this last time we had the Does Bioretention Work webinar, if a conventional bioretention system is appropriately designed, installed, and maintained, it should provide a very good stormwater treatment function. Now, the data might not be there to unequivocally demonstrate that, but yeah, look, I think that's still a reasonable call to make. And again,
absolutely,
yeah,
absolutely. I think if you get the organic material right, from the type of material and the quantity of material, and you're controlling your specification, yeah, you could expect a good outcome. It's just that I don't think we've seen that tested yet here. Well, at least here in Australia, anyway, we haven't seen that. So, but again, you know, hats off to Blacktown Council for sort of embarking on their testing program to look at this data.
Cool. So is this claim accurate? No, I'm going to say it's busted. I'd actually argue that at least based on the data that's available currently, proprietary assets, at least Ocean Protect assets, particularly the Stormfield and Filterra, are probably more likely to achieve, I'd have more confidence in them achieving better nutrient removal relative to conventional bio, at least based on the data that's available to date. Now, again, maybe we'll get more data in the next few years, but until then, I don't believe this claim is accurate. No, so in conclusion, in summary, it is my opinion, again, I've got a conflict of interest, but my opinion is that many of the cited concerns about proprietary assets are just not justified, at least with respect to Ocean Protect assets. Now, that's a general summary, and I'd really encourage attendees to fact check me or fact check me, myself and Michael. Now, I've provided a whole bunch of references here to the studies, the field studies that I've referred to. I'd really encourage others to look at the data, make sure I haven't made anything up, and maybe if there's other studies, assess them as well. I've tried to be as exhaustive as I can, but look, something might have slipped past the net. So in terms of recommendation as well, my key recommendation is opinions that are not substantiated with appropriate data or proof should not prevent best practice. And now, unfortunately, some councils do have a blanket rule of no proprietary assets because of these concerns. If these concerns aren't justified and they are leading to poorer outcomes in terms of protecting our waterways from pollution, I don't believe that's appropriate at all. And also for the engineers and consultants dialing in today, my recommendation to you guys would also be to ask us to compare options. You know, if there's concerns around costs or whatever, we're more than capable of doing a comparison between our assets and also the conventional bioretention systems, wetlands, et cetera, which we have no commercial interest in. we are very capable of modelling, designing, or at least doing a preliminary cost assessment of other non-Ocean Protect assets. Prior to joining Ocean Protect, that's all what I did. I modelled and designed a whole bunch of bioretention systems. So I'm pretty sure I can do it, or at least pretend to do it anyway. And so, yeah, we can do that options analysis, life cycle cost analysis, and we will do it at no charge. So if in doubt, please ask for help. We are more than happy to model conventional bioretention systems, particularly handy if you don't have a music license in particular, or just uptime Paul, and who isn't? Now, this brings me to my final bit. We had a lot of, you might remember I raised this at the start, we got a lot of people that raised issues and concerns. So we had 220 registrations. A lot of people wanted some sort of, that they were given the opportunity to raise issues and concerns. And these are some of the things that we've, the feedback we got, literally word for word. So I'm going to, what was it? So it's stuff on maintenance, costs, performance, and approvals. Look, I think for the maintenance items, I think we generally covered those reasonably well. I know we had a doozy from Blacktown. They asked, what provides councils the legal right to enforce compliance on private properties? Now, Blacktown Council are using the positive covenants and restrictions on the use of land, Section 88 BS, but I would be curious to know what other opportunities and options are out there. Michael, do you want to have a crack at that one?
Thanks, Brad. Probably the most hardest question on the whole thing. But look, yeah, look, they've used a positive covenant and created a Section 88B instrument to give right of carriage over the site, and that's done through the development application process. So, and that's typically where all the power is with this and getting maintenance done. So I think they're on the right path, and that probably seems the most effective way to do it. So you've got, you know, and if you look at this, it's tied together with maintenance contracts. So they sit there and say, look, you need, for any asset, you need a 5-year maintenance contract. So, okay, that's fine. And they're also putting in the 88B instrument to sit there and say, hey, you know, anyone, well, basically council or the people maintaining the system can go on site at any time and access that technology. So it's probably the neatest way that we've seen, without creating further legislation on maintaining these things, tying it to the permitting scheme development applications and creating positive covenants. This seems to be the best way to go, in conjunction with the maintenance contract itself. You need both to go hand in hand. So I haven't seen anything else that's really come close to that, honestly, all across the East Coast.
And obviously we're seeing in many councils requiring long-term maintenance agreement for stormwater treatment assets, mainly proprietary, and I'd suggest that the same needs to be applied for non-proprietary as well. To get a DA approval, you need to have some sort of long-term maintenance agreement to make sure that the assets are maintained, whether it's proprietary or non-proprietary. And to Michael's point, if there's some way for council to enforce that maintenance activity, fantastic. And kudos for Blacktown City Council for leading the way in that regard. In terms of costs, I think some of these, I think most of these issues were addressed. Where can I find maintenance contract? Sorry, where can I find maintenance costs? Look, if it's Ocean Protect, ask us for a quote. The costs do vary from site to site. You know, a device that to get maintained in this, you know, Blacktown's probably going to cost a lot, or may cost differently to an asset that's out in the boondocks of Townsville, for example. So it is site specific. So, but if in doubt, please ask us for a quote. In terms of performance, we covered the nitrogen, dissolved nitrogen, independent research. Look, I've presented those informations. Ways to monitor performance. Look, you could always get
I could spend all day. How long we got, Brad?
Look, Ocean Protect could obviously do it for you. But if you'd like to see how it's done, the review papers that we have for ocean guards, jellyfish, storm filter, Filterra, which are all publicly available on our website, pedantically detail the methodology used. So to what extent has there been third-party peer reviews validating? Look, again, I can only, sorry, that's for non-proprietary. If I just comment on Ocean Protect assets. So for the assets I just mentioned, jellyfish, ocean guard, storm filter, Filterra, the performance studies have all been peer reviewed. All those peer review reports are in the review papers as well, which again are publicly available. Third-party reviews validating the effectiveness of non-proprietary assets. Well, look, there is obviously studies out there, and I've referred to some of those. But again, I think it'll be really interesting to see what data comes out of the Blacktown City Council assessment as well.
Absolutely. And I think, Brad, if just looking forward to one of our next webinars with Professor Bill Hunt, I think that question there would certainly be addressed, because I know that Professor Hunt's done a lot of work on monitoring bioretention systems over there in the United States. And I think that question would certainly be answered in that next webinar.
Yeah. Shameless plug for our next webinar. Approvals, the bane of my existence. What kind of assets have been installed in the Melbourne area? Like Ocean Protective have installed many assets across Melbourne and Victoria. Some councils do allow proprietary assets, but some just don't. But certainly we've had a lot of assets put in the ground. A reference to the Melbourne Water Guidelines. Look, Melbourne Water have made it very clear to us, at least, that they don't endorse, or they're not in a position to endorse or not endorse any type of asset. So they don't want to get involved in that space, and they don't believe that's their role at all. So it's a really hard one. Having said that, a lot of people do look to Melbourne Water for advice, and their current music guideline does talk about, this very issue. But the latest advice is they're not in the position of endorsing or not endorsing any asset type. Approvals, look, it varies from council to council. I could talk all day about this, but look, a lot of our assets are approved for use in various councils across Queensland, New South Wales and Victoria. Generally, where proprietary assets are used, our assets are approved for use. Michael, anything more to add on approvals? You can talk about this all day.
Where can we go? Look, I think that probably the best thing, if you're trying to deal with a council that's not approving products or doesn't have an approval process, point them to someone that does. So in the case of down there in Victoria, look, if the council follows Melbourne Water's lead, but Melbourne Water doesn't want to get involved, look to another council and see what they've done. See how they've integrated some products and see what they do. Yeah,
it's worth noting, we had a conversation beforehand. We've been putting these assets in Blacktown City Council for 20 years. And, Blacktown City Council, leading council, doing a great job with water sensitive urban design. And despite that, a lot of small councils will just go, no, regardless of what's been happening elsewhere, we just don't want these assets in the ground. Largely because of these claims, these, things that I've sort of tried to address today. So that's I guess, the rationale for this webinar. What is the most robust? These are a whole bunch of miscellaneous questions. What is the most robust system available? In short, it's very site specific. So it depends, basically. Classic consultancy answer. Michael, anything more to add?
One that's appropriately sized.
Yeah. Cool. I guess one question we often get is, how easy is it to swap between different proprietary assets? E.g. swap a spell filter in the ground with a storm filter, or vice versa. Michael, another great question for you.
Gee, Brad, you're really giving me the great ones. So it's fantastic. Look, I can talk about putting a storm filter into a spell filter installation. For us, it's pretty easy. We go in there. We basically put the pipe in, put a false floor in, and screw the cartridges in. So relatively straightforward. And we have 3 different cartridge heights with 3 different head losses. So we can adjust the weir to make it work. So yeah, for us, relatively straightforward. The other way around, I'm not sure how easy or hard that is, really, to be honest. But certainly us moving that way, it's relatively straightforward.
Cool. If you've got questions you'd like to, and there's a few questions coming through, so thank you for those. But I guess as a reminder, if you do have questions, please put them in the Q&A. Just a shameless plug, Michael mentioned we've got our next webinar is on Thursday, the 28th of April. To register, just head to our Ocean Protect website. That's all I had to cover today. If you'd like to talk further, and we don't talk about I'm going to try and respond to some of the questions that are posed now. But if you'd like to talk further after today, feel free to reach out to myself or Michael. More than happy to talk about this sort of stuff or anything. Some of the issues, some of the questions that we sort of just very quickly try to address. Some of them I may have missed. But if you think your question hasn't been appropriately addressed or answered, or you want to talk about something else or whatever, please drop us a line. But I have had a few questions come through, so I'm just going to charge through to those just now. So a question from Jared, who says the per dwelling cost, which is the Gold Coast analysis that I showed before, the per dwelling is a nice way to look at it. Did you have a reference rate for the same terms for bioretention systems or wetlands to compare? No, in short. So we were purely looking at Ocean Protect maintenance contracts. I would love to see that sort of analysis undertaken. But I have not seen anything like that at all. It may actually be best to actually approach the likes of companies that actually do provide the maintenance services for those sort of devices, Renew Solutions, Wave Maintenance, for example. They might be able to provide you a reference rate. And it'd be something I'd love to see in the industry. Alan Walker asks, the big issue with conventional biosystems is the filter media used. Often too fine and it clogs and infiltration is poor. Other plantings are often excessive and congest the effectiveness. Yeah, look, it's something we've talked about at length. We've had webinars on the very topic of the suitability of bioretention media and the appropriateness of specifications. And I guess the key deficiency is around whether the specification that's claimed by the provider is actually consistent with what's actually delivered. Yeah, look, there's a lot of, I think, improvements that can be made to bioretention media without a shadow of a doubt. We're certainly seeing high rates of clogging. Now, whether that's due to the media itself or probably more likely, a lack of pre-treatment, for filtera systems, we do use a layer of mulch. I honestly believe we should have that on all conventional bioretention systems and maybe with additional pre-treatment upstream in some circumstances as well, whether that's a GPT or a SED4 bay or whatever. Michael, anything more to add?
Yeah, look, hot topic at the moment. There was a tender recently that we missed for the manufacturing of filter media for Blacktown City Council, and they were looking at this exact thing, mass producing bioretention media, and they were playing around with a few designs. So the fact is, 20 years after, we started seeing bioretention systems go in the ground, we're still tweaking with the blend and trying to get the QA QC right on these larger batches. So yeah, there's a heap of issues there, and we're trying to get I think they're trying to still balance the PSD with the organic material to, give you a decent infiltration rate, but also make the plants grow. It's a very fine balancing act to get all those things in unison, and to get a basically living thing to treat stormwater and thrive. It's quite complicated. So, but yeah, there is still some issues, I think, there, and especially looking at, organic material contents at 20 and 30%. Certainly up there. You'll get plants to grow in it, but will you get also leaching of nutrients? You might. So I think there's still a few issues there that need to be resolved, and hence the reason why people are putting tenders out to tweak the blends and provide product.
Angus Lim asks, and it's a tongue-in-cheek question: Is it illegal to not maintain stormwater treatment assets? He's obviously referring to my Frank Sydney presentation that he was in attendance for. We'll actually have a webinar about this. I'm organising this as we speak to discuss the legal framework around whether it is illegal or not to maintain stormwater treatment assets. But Angus, you and me both know the answer to that question. John Hudson asks, are there any councils in South Australia that use your products? Councils that use our products, we certainly have a lot of our assets in South Australia. I'm just trying to think, Michael, has any councils actually used our devices?
Oh, Brad, you've got me here.
Put me on the spot. I'm not sure if I can think of any councils that have used, but certainly we've installed various assets within South Australia for sure.
Private development, yes, absolutely. Yeah. Councils, I believe there is some on the horizon. And someone will probably correct me and say that we have done a couple, but yes, there we go. West Torrens, there we go.
West Torrens, yeah. And we are in discussions with a couple other councils around doing some microplastic analyses as well through our ocean guards as well. And that would be a council asset. But that's for another day. Christian Leonardo asks, can you send some information on Ocean Protect assets installed across the Melbourne area? I will, Christian, just for you. So yeah, like I said, we have installed various, I think the full gamut of all our devices in various locations around Victoria and Melbourne. And I can certainly provide some information in that regard.
I think our first system was Gosh's Paddock down there, probably going back 12, 13 years ago. and that was a storm filter. So yeah, we've been around there for a little while, I suppose.
Yeah, cool. But look, can you believe, Michael, we are on time. So we've charged through a lot of, oh, hang on, I'm getting some final questions coming through. Oh, it's just a thank you. That's okay. So look, thank you everyone for your attendance today. It's been greatly appreciated. The recording and slides will be made available on our Ocean Protect website. So if you're keen to learn more, please feel free to jump on our Ocean Protect website under webinars. I'll put a link in shortly. Again, a shameless plug for our next webinar, April 27th, with Bill Hunt from University of North Carolina, which will be a doozy. And we're looking to probably put out some sort of a very small summary sort of report around what we've talked about today. So again, if you've got any further questions, feel free to reach out to myself or Michael. But thank you guys so much for your attendance today. It's really appreciated. And thank you everyone for all those questions that have come through in the registration and today. Hang on, I'm getting a
couple more, Brad.
Couple more, sorry. Spoke too soon.
Just yet.
Glenn Allen says, you mentioned microplastics. Any thought on filter effectiveness with regards to removal of microplastics? It's a great question. So there's been some studies around the removal of microplastics for various asset types, including bioretention systems. And I remember there's one that's remains in my brain around bioretention systems actually achieved really good removal of microplastics. I think it was like 98%. I can't remember what the study was, but it was running about that. But yeah, look, anything that's going to be removing sediment and silts is probably going to go a long way to removing microplastics as well. So Michael, do you have anything more to add?
Yeah, because really what's the difference is probably the specific gravity of the pollutant, really. So, you know, if you look at, say, microplastics, it's just a particle, but with a lot lower specific gravity. So it would tend to, you know, be closer to 1 more or less. So yeah, any filter that has some sort of physical screening will get you some microplastics, and depending on the, you know, PSD or the depth of that filter bed or the opening size of the membrane will determine how effective it is. So yeah, I wouldn't be surprised that what we're seeing, you know, sort of 70-80% reductions in microplastics for, say, a bioretention system or, you know, some sort of media filter. That is totally plausible, and I think that, you know, I think that will be an area of further research in the next few years, because it definitely is a hot topic, and it's something that's not closely monitored. We look at suspended solids, and we look at, you know, total volatile solids, look at the organic material that's running through, another solid, obviously microplastics. So I think that will be something that comes out in the next couple of years.
Look, let's let's wrap this up so we look like we finished on time, and we are 3 minutes to spare. So again, thanks for everyone who's dialed in today. Much appreciated. Look forward to seeing you at the next webinar. If you'd like any further information, whatever, or want to chat to Michael and myself, please reach out. But again, thank you so much for coming along today, and enjoy the rest of your day.